Here we go, Unit 6, Skill 2. Alright, so roots of multiplicity. So the essential question, how can we find the following properties of a polynomial, which would be the, let's say, degree, the roots, crosses versus bounces, and leading coefficient. I'm going to read that again because, well, the handwriting is not great, I'm sorry. So it's how can we find the following properties of a polynomial? The properties we care about are the degree, the roots, crossing versus bouncing, crosses versus bounces it says, and then the leading coefficient, and that's abbreviated. Alright, so take a second, pause the video, read through, alright, highlight, annotate the important information, then we'll go back through, I'll discuss some of it pretty quickly, and we'll take notes on the last page, do some practice problems, be done. So, the degree of a polynomial, alright? Kind of important, something we need to be able to do and understand, know. So, the degree is really just the highest power. So, when we take a look here, the highest power is going to be the n right there. And that's pretty easy. We just go with the highest power and we're done. Okay? But if a polynomial is in factored form, okay, we have to find the degree a little bit differently. Meaning we take the powers on x. So we take this x2, 3, and there should be a little 1 written right there, and we add them all up. Because if we were to multiply it all out, and nobody really wants to do that, but if we were, we would end up with x to the power 6. So if I had another question that had an x squared and times x plus 1 to the third, that would be degree 5. And then if I keep going and add x minus 5 to the fourth, when all of a sudden I have 2 plus 3 plus 4, that's going to be a degree of 9. And so on and so forth. That's pretty straightforward. The degree of the function isn't so bad. The roots, the zeros of multiplicity, a little bit more challenging. So we start off with this first one. We're talking about x minus 3 or x plus 3, x minus 2. That's obviously going to have zeros at negative 3 and 2, each occurring one time. But this next one, where we have the exact same zeros, but to a different power, has the same zeros, x plus 3 and x minus 2, so it's going to cross at negative 3 and 2, but it has a multiplicity, meaning the x plus 3, or the x equals negative 3, occurs 4 times. So it's occurring that 4 times. The x minus 2, or x equals 2, occurs 7 times. So we talk about it with multiplicity, so we would say that x equals 2 has a multiplicity of 7, okay? And then the x plus 3 has a multiplicity of, x equals negative 3 has a multiplicity of 4, okay, because it occurs that many times. Multiplicities show up a little bit different on a graph, okay. If you take a look down here, you can see odd multiplicity, which kind of talks about in the reading, right, crosses the x-axis. So odd multiplicity will cross the x-axis, whereas even multiplicity is going to bounce off the x-axis, and that's important that you understand that. So take a look at the picture, and let's see what we got going on here. So I have x plus 1 to the, x plus 6 to the power 1. Let's make that something we can see. And x minus 7 to the power 1. And what you want to notice is that, hey, look at that. Right here, it's crossing. It's crossing. So the power was 1, the power is 1, and it crossed both times. We'll now take a look at the graph again. Now I take and square this. So again, I still have a power of 1 right here. Okay, so x plus 6, we'll take a look at x equals negative 6. At x equals negative 6, which is what you would get if you set that equal to 0, it crosses still. But now at x equals 7, it's bouncing because of that 2. It's an even number. Even multiplicity bounces off the x-axis. So now we take a look and change it around again. X plus 6 squared. Okay, well, that would be x equals negative 6. It's bouncing off of it because it was a positive 2. It goes back down. It occurs twice. X minus 7 only has an exponent of 1, and look at that, it crosses it. And then take a look at what happens when you have a polynomial of degree 4. All right, take and add the two exponents, 2 and 2, that's degree 4. All right, we have a bounce and a bounce, so at negative 6 it bounces, and at x equals 7, it bounces again. That's the idea of roots of multiplicity. Moving on. So, the following graph is an 8th degree polynomial. All right, list the polynomial zeros with their multiplicity. Well, you can kind of see the zeros pretty easily, right? Negative 15, it crosses at a minimum of once. Negative 10, well, that's a bounce, so that means the exponent has to be a minimum of 2. Again, another cross, 1, another cross, 1, another bounce, minimum of 2, another cross, minimum of 1. The problem with looking at a graph is that we don't know exactly how many times that zero of multiplicity occurred. So right here we have it occurring at minimum of 1. And if you take a look in the reading, it says something to that effect, right? There is no way to tell from the graph. So the odd multiplicity zeros might occur only once, or might occur 3, 5, or more times each. So when we write this x plus 15 with a power of 1 right here, because of what we had up here, we don't know if it's really 1. We're kind of making an assumption that it was the lowest power possible, but it could have been 1, 3, 5, 7, 9, or any odd number. And the same goes for all the rest. So when we have x plus 10, we get that right from here, x equals negative 10. We're assuming it's the lowest power, but it totally could have been a 2, 4, 6, or an 8. And to give you an idea of what's going on there and why it can be that, take a look at the pictures that we have below us. So when you see a multiplicity of 2 down here, right, it bounces off of it. Okay, that's an actual multiplicity of 2 with x squared. Take a look at the difference between x squared and x to the 4th. Is there much of a difference? The answer is not. It pretty much looks the same. It only hits the one time. It's a little bit fatter in the bottom, I guess. And then you take a look at a power of 6. When the multiplicity is 6, well, you know what? It still only hits the one time, and it bounces, right? It still bounces, but there's no real way to look at it and say, oh yeah, that's multiplicity of 2, 4, 6, 8, or any number, any even number. So we tend to say, let's go with the lowest if we're coming up with it. But it could have been 2, 4, or 6 for any question. So odd multiplicity, same idea. All right, when you have 1, it will be a nice straight line. Multiplicities of 3 or higher tend to do this little bit of a curve here, okay? But sometimes you can't see the curve, so we go with a multiplicity of 1. But if you see a little bit of a jog to it, then the multiplicity is usually 3 or higher, okay? Take a look at the 5. It looks like it still does the same thing. It's still only crossing at one spot for our x to the 5th here, but that has a multiplicity of 5. Take back a look at this example up here, all right, and it says specifically, oh, that we have a, what is it right here, an 8th degree polynomial, all right, and I'm solving this question. Now that I know that little tidbit, that it's got to be 8th degree, well, if I go with the minimums of 1, 2, 1, 1, 2, 1, which is right here, you can see 1, 1, 2, right, 1, 2, 1, and you add those up, you end up with 8. And so when a question occurs like this, they're going to say the minimum, right, that you could possibly have. And they're not going to give you a power of 10 for this one or a power of 12 or 14, because if we did give you a power like that, you wouldn't know whether to make this one 2 or 4 or 6 or make this one 2 or 4 or 6, because there's no way to tell by looking at the picture. So when we give you questions like this right here, we're going to give you the minimum possible that it would be, and then you'll have to go with the minimums here. So this has got to be 1, this has got to be 1, this we're going to go with a minimum of 2, minimum of 1, so on and so forth. So let's jump to some questions. So the degree of a polynomial in factored form, that is just where we take and add all the exponents on the variables. So we have, you're going to add the exponents. Okay. Add the exponents. Don't forget about exponents of 1 when they're not written. So we would take 3, 2, and the 1 that's not there. 3, 2, and 1 added up. One good day is 6. So it's a polynomial of degree 6. I don't know why that stopped writing. Whatever. So the zeros of multiplicity are the number of times a factor appears, that's bad, in a polynomial. So x equals a appears n times. Or happens n times, and x equals b appears or happens or shows up as multiplicity of n times. Okay. So even multiplicity. The graph bounces off of the x-axis. So we see here it bounces off of it, multiplicity of 2, slightly a little bit wider. It bounces off of it, multiplicity of 4, still bouncing off of it, but a little bit wider, multiplicity of 6. Odd multiplicity. The graph crosses the x-axis. So, and again, two different ways we can cross. If it's a multiplicity of 1, it will be a nice straight line. As soon as you see that curvature where it crosses once, right, that's either going to be 3, 5, for the exponent 7, 9, so on and so forth. But if it's a perfectly straight line, multiplicity we can go with is 1. Let's jump to some problems here. Alright, so the degree of this first problem is going to be our exponents added together. 2 and 4 makes 6. Alright, the leading coefficient is a importantly positive 3. We don't really care that it's a 3 so much that we care that it's positive. The roots are going to be x equals negative 1 and x equals 3. Where is it bouncing versus crossing? Well, bounces happen when we have an even exponent, so it's going to bounce at negative 1 and also at 3 because they were both crossing. It is not crossing at all. Okay. You should remember that the degree 6 means that it is both pointing up or both pointing down from previous classes, and end behavior will answer once we get to the question we've drawn it. So we have a root at negative 1. So here's negative 1, and here's 1, 2, 3. So we have a root right here at our negative 1. We have a root right here at 3. What do we know about the root? Well, we know it's bouncing at that root. So now we have to imagine what's kind of happening here. We could type in the calculator, that would be kind of cheating and it kind of defeats the purpose, and it's not what I'm expecting you to do. So the end behavior is something we got to talk about, think about. So if it's a degree of 6, it's either going to be both pointing up or both pointing down. Okay? In this case, it's the both pointing up version because it is a positive leading coefficient. So again, degree of 6 looks like this or this at the ends. It's positive, so it's going to be this guy. So it's got to look like that, and it's got to look like that. Now obviously right here it's going to be bouncing, coming back up. Must go back down at some point, bounce again. Okay. We don't have specifics on the max or min because we did this by hand. So we can label our maxes. Right, this guy right here is a max. This guy right here is a min, and so is this guy. Okay, so max would be 1, mins would be 2. The end behavior, as x approaches negative infinity, y approaches positive infinity, and as x goes to the right forever, y goes up forever, positive infinity. So as we go to the right forever, we're going up. As we go to the left forever, we're going up, which is why both of them are positive infinity. Moving on, let's do the next question. Alright, so we see in this particular problem we have a degree again of 4. Alright, so we have 1 plus 2 plus the 1 here gives us our degree of 4. The leading coefficient is positive 2, and again we care more that it's positive than that it's 2. 2 really doesn't matter to us. The roots, alright, the roots are at negative 1, at 2, and at 3. And we simply find the roots very easily by just setting them equal to 0. So if you really wanted to, you could write x plus 1 equals 0, right? X minus 2 equals 0, and x minus 3 equals 0. And that came from each one of these guys right here. So obviously when you subtract 1, you get negative 1. When you add 2 over, you get x equals 2. And when you add 3, you get x equals 3. Alright, so the bounces occur when we have an even exponent. So obviously right here is even exponent. That was for the 2. So we're going to have a bounce at the x equals 2, and we are going to be crossing at our -1 and at 3. The end behavior, when we have degree 4 that's positive, again, it's going to look the same as the previous one. Okay, even degree means it's both up or both down. In this case, both are up because we have a positive and it's an even degree. So that's our end behavior, what it's going to look like. We'll take a look at that in a second and write that down once we have the graph. So now we need to make our sketch. Try and make this as even as possible. So 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, so we have roots at -1, 2, and 3. Alright, we know it's supposed to be going up this way. So it's going to come up. We said at -1 it was going to cross, so it comes down below. And at the 2 it's supposed to bounce. So that's going to be kind of weird. It's going to come down, come back up, hit it, bounce off of it, come back down, and then, well, it's got to cross at 3, so it must have to turn around and come back up. Now, I don't know for sure if I'm 100% right and it went low here or lower here. Maybe it went way down here and it bounced and up back up. I don't know that for sure. I'm just ballparking it from that perspective. But what I do know is that it should be bouncing right here. It should cross at the -1 and it should cross at the 3. So with it having to end this way and this way because it's degree 4 and positive, I can get a general sketch of what the graph should look like. So end behavior. All right, as x approaches, come on, get going. As x approaches the -infinity, our y, or f of x, is still approaching, right? It's going up forever, it's positive. And as x approaches positive infinity, as we go right forever, we are still going up forever. All right, maxes and mins. Well, looks like we have one max that's occurring right here. And we have a min and a min here. So we have, again, 2 mins, 1 max, total of 3 turning points, which makes sense because the degree is 4, so we'll have 1 less. All right, moving on. Last question. It says, write the equation of the 8th degree polynomial. All right, so here's where we take a look at it and we ask ourselves, is it crossing or is it bouncing? And we're going to go with the minimum degree that we possibly can find. So right here, we have a bounce. Okay, right here, it's a cross. Right here is very clearly a bounce. And then this guy right here is a cross. Okay, so now we're going to start to write the equation for it. Alright, so it's an 8th degree polynomial, means the exponents all have to add up to 8. First going to go through and find my roots, so it looks like -3, -1, 1, and 4. So if I had x equals -3, x equals -1, x equals 1, and x equals 4, the factor that I would have had would have been x plus 3, I would have had an x plus 1, I would have had an x minus 1, and I would have had an x minus 4. So now I need to come up with the exponents on these bad boys. Well, we're going to go with the minimum possible exponent first, and hopefully that will work out. Typically does when they give you an equation. So we have a bounce here. The minimum exponent that we'd have to have would be a 2. Take a look at the next one. See how it's crossing, but it's a nice straight line crossing. That minimum exponent can totally be 1. Okay. The next guy that we have here is another bounce. It comes below, bounces off the x-axis and goes straight back down, or goes back down, not straight. So that minimum exponent, when it's a bounce, has to be even, so therefore 2. And the last one is a little bit weird. And it kind of works out in our favor that it is weird. But you see how when it's crossing right here, it does this little jog where it almost looks like it goes flat? Okay, when you see that, that means it's not going to be a 1 for the exponent. It's going to be a minimum of 3. Which is nice because when I take and add up my 2, 1, 2, and 3, that gives me 8. And that is my equation. So y equals, okay, y equals x plus 3 squared, x plus 1, x minus 1 squared times x minus 4. Now, You could have a little dot in between here if you wanted, but writing these next to each other anyways means multiply, so we're good to go. Now, if it didn't say write the equation of the 8th degree, if it didn't say that, here's the problem. This guy right here could have been 2, 4, 6, 8, 10, 12, 14, 16, and so on and so forth. This guy right here could have been the same. This could have been 1, 3, 5, 7, 9, and obviously 3, 5, 7, 9, so on and so forth. So there's tons of different answers if they don't say that the polynomial has to be degree 8. So we go with the lowest exponent. Now this isn't the exact equation, but it's our best guess for the equation of this polynomial in factored form. We'll get into exact equations next class. Don't forget to write your summary, do your practice, and come up and show it to us. Thank you.